What is UV mapping and why are we doing it? If you saw my mini course on Blender for complete beginners, I promised to cover two main areas. One of them was UV mapping, often shortened to UVs, and the other was shading. So in this video we are starting with the first one, and that is UV mapping. So what is UV mapping? It means we take a 3D object and flatten it out into 2D space. In practice, it looks like a cross when you cut and lay out a cube. You can also imagine a chocolate bunny that has a wrapping around itself. If you cut it properly, you could lay it down on the table. And that's pretty much how UV mapping is. You have a texture that you are wrapping around. This process is called unwrapping or sometimes unfolding. That depends on the software you're using. Everybody calls it a bit differently or has it under a different name. It should pretty much be similar in most softwares. Now, why do we do that? This was a quick overview of what UV mapping is. Now let's look at why we actually need it. UV maps can be used for multiple things, such as light information, detail information, but mainly they let us wrap a 2D texture around our 3D model. It's how we can paint or apply color to model easily and accurately. For example, if we want to put our logo on a 3D model, we do it in a 2D space, which is then projected back into the 3D space. And you might be asking, why are we doing this in 2D space? Why don't we just use 3D space right away and skip this preparation in 2D, which could be time consuming and sometimes difficult? Well, here's why. 3D models are made of polygons, little squares or triangles connected together. The more polygons there are, the more demanding the model becomes on your hardware. And texturing directly on those polygons can be unproductive. That's because one polygon represents one pixel. So imagine trying to match a detailed 2K texture, which is 2048 by 2048, with polygons. If you were to work with such a high poly model, it would be very difficult to move, save, or make changes across your pipeline, especially when collaborating with the team. Now, the other reason why we need UVs is pretty much practical. They give us simplicity. For example, if we take a cylinder and want to texture it, we can UV map it in a way that the parts of the model are straightened. Then in 2D space, we can wrap the texture on the straight section, which will project back onto the curved part in 3D. And that's much simpler than if you were to try to put the texture in a 3D space and match it on the curved part, when in the 2D it's straightened. So there's really simplicity in this workflow that the 2D space offers. That said, UV mapping can take a lot of time. Some models are simple and done quickly, but others are more difficult and time consuming. In those cases, we can generate UVs using automatic functions, especially when you don't care about the output and you just need the model in a 2D space in any shape it generates. Most of the time though, it's done by hand and it's inevitable that it takes time. Even simple models in a large number can take a lot of time, and you don't always have time to do it. So there are instances where we don't need UVs and we might not want to use them. And how does it work when we don't need them? If you watched my mini course for Blender, you saw me using generated function when applying a texture on a model. Sometimes we don't have to touch the UVs at all. We can use this generated function in Blender or just generate and use auto UVs, but the software generates it all for us. All of this is done automatically, but if we decide to use generated in the shader, we don't have much control over the output and we have to be fine with what we get. However, if you're doing something like a metal surface or sand, you don't always need to bother with UVs and generated methods can be enough. That, however, doesn't apply to all programs or to all users, since not everybody knows how to work that way or want to work that way. Knowing when to go which way in your workflow comes with experience, and it's something you'll learn along the way. Now, another way we don't need UVs is through polypainting, or sometimes called vertex painting, where we paint directly on the polygons or vertices. In this case, we need millions of polygons so the texture doesn't look pixelated, and that also requires good hardware to run. This is a favorite method for ZBrush users because of the nature of ZBrush, where you work with high poly meshes and then screenshot them or export the result into Photoshop to finish it without having to export the model anywhere or share it with anybody else. Therefore, you don't encounter any of the issues that could make the workflow difficult. Then there are automatic ways to make UVs. In Blender, we can generate auto UV using an angle-based approach, where you can define at which angle the cuts will be made, and Blender will output something for you. Generally, this gives you a result that you can work with, but not necessarily something anybody can clearly follow or understand. To make UV mapping, we have to unfold the model. We need to make cuts that open the model in a way that allow us to flatten it into 2D space. If we try to do this without any cuts, we would just get all parts sitting on top of each other. It would look like something squished under a metal press. That way it's flattened but not laid out. What we do is we cut it and then we flatten it. This way we get separate pieces and a readable result. Each software has its own way of doing it and its own name for it. Blender unwraps, Maya unfolds, and ZBrush uses UV Master to unwrap. Then there's dedicated software just for this called Resume UV, but that's another tool to learn and it's often unnecessary unless you have a specific need. Nevertheless, all of these programs work similarly. You cut the model, you lay it out. The main difference is how each program handles the stretching. Each piece of software has its own algorithm to calculate the unwrapping, and during this process, stretching can occur. How much stretching you get depends on how well you cut the model or on the method the software uses. Some programs offer different modes for organic or hard surface models, and they give you more control, but it varies. You should be able to understand this much more after the demo video, which I will do after this one, and you will try it out with me, so don't worry. During the UV mapping, we also do what's called packing, which comes after cutting. Just like with unwrapping, each software has its own way of doing the packing and offers different options, but the core idea is the same. So what is packing? When we unwrap and cut the model into pieces, we get multiple parts laid out, usually inside a square UV space, and the process of arranging those pieces is called packing. The reason we pack is to avoid overlapping pieces, because overlapping means they are going to share the same pixel. In practice, it would look like this. Sometimes it's handy and you would want to use it, but most of the time you want to pack your UVs with some distance between the individual pieces, which are called islands, and have the same size that they share, which is also very important. And for that we use Texel Density. Texel Density sets how many pixels are covered by piece of our model. It's measured in pixels per unit, and the more coverage the island has, the sharper and more detailed texture appears. The smaller the island, the fewer the pixels it gets, and the lower the texture quality. This might be hard to imagine, but in a demo you'll understand it a bit better. What you need to remember is that when the model is being prepared, all those cut pieces in 2D space need to share the same or similar texel density, which means they need to be covering same amount of pixel per the size they are representing for the texture to look consistent. For example, if you use letters or numbers on your model and put one letter on one side and another on the opposite side, having the same density will make them the same size. Different texel density would make one appear larger than the other, or vice versa, and that's why texel density matters. All of these things can be done in Blender. There are ways to simplify this process, including add-ons or external programs you can get. But basically all of these 3D softwares offer a way to process UV maps and tools needed to have them done. So you don't have to worry that if you are using some different software that it wouldn't be available there. It should be. Most of the 3D packages cover it. Alright. So now that we have gone over the fundamentals, we can move on to the next video where we'll apply the knowledge we have gathered. But before we do that, let's summarize our information. UV mapping is converting a 3D object into 2D space for optimizing and simplifying the workflow so we can apply 2D textures. It's not always necessary. We can skip or generate UVs if we know what we are doing. All tools we need for this process are available in all 3D packages, so we don't need to worry about external programs unless we need something specific, but even so, most of the tools are similar. And lastly, size of each pieces in UV space are important. We use texel density to measure and set the size to keep consistency of detail in texture. That's it. Let's get to the next video, which will be slightly longer because I'll be commenting and working along the way. I'll remind you of some key points we have covered, and we'll try everything out in practice on a model I'll give you for free on a gumroad. The link will be available in the video description, but I need to make the model first. Alright. Thank you for watching. If you have any feedback for me regarding these videos, please let me know in the comments, and I'll see you in the next video.